All right, here we're looking at section 9.8, and this is some information that needs to go with what we looked at last unit, or last section, with some of those trig identities. We're going to be looking at some different trig identities. We're going to be looking at the sum and difference formulas, really, so you need to make sure that these are written down kind of in the same spot where you have your identities. We're going to use these sum and difference formulas to evaluate and simplify trig expressions. Then we're going to use these identities to solve some trig equations and rewrite real-life formulas. So here are my sum and difference formulas, right? So make sure that these get written down somewhere where you can find them often, because we're going to use these quite a bit. And these are not things that you really need to memorize. So the first thing, we want to find the exact value of sine of 15 degrees. So the other thing we need to know is we're going to be using our unit circle a lot for this. So here's my unit circle. We want to be dealing with numbers and values and angles that fall on my unit circle. Because if they fall on my unit circle, I have the exact values given to me. If it does not fall on my unit circle, I don't know what those values are. So here I'm looking at sine of 15 degrees. Well, sine of 15 degrees is not on my unit circle, but I can get to 15 by taking 60 and subtracting 45. Both of these are in my unit circle. So now I see that I have the sine, I'm using the sine, and I have the difference. So I can go ahead and use my difference formula for sine. So I've got sine of 60 cosine 45 minus cosine 60 sine of 45. So now I look at my unit circle for both 60 and 45 degrees, right? So here's 60. I've got my cosine and my sine, and my 45, I've got my cosine and my sine. So now I can use those values to help me evaluate. So now I just plug in what I had. So I had for the sine of 60, I had square root of 3 over 2. Cosine of 45 was square root of 2 over 2. Cosine of 60 was 1/2. And sine of 45 was square root of 2 over 2. And then I can just simplify by multiplying, and I can leave it here. So this is my exact value of the sine of 15 degrees. I could check it with a calculator as well, just to make sure that we're right on. But we always want to leave our exact answer here. So now we're going to be looking at tangent of 7 pi over 12. So I don't have 7 pi over 12, so I can look at this, and this is going to be the same thing as pi over 3 and pi over 4, right? I just broke this into pieces that I know that are on my unit circle. Okay, so now I use my sum formula for tangent, so then I just find what I have, and then I substitute and evaluate what I know from my unit circle, and then I can simplify that. So then my exact value for this tangent of 7 pi over 12 is -2 minus the square root of 3. So the first thing I always have to do is figure out how can I break this piece into chunks by either adding or subtracting things that I have in my unit circle, because that will allow me to use my exact values. So then again, I can just check my final answer with a calculator to make sure that I was right. So here we have cosine of a minus b, given that cosine of a is -4/5, with pi is less than a, which is less than 3 pi over 2. So here I know I'm in quadrant 3, so I know that sine of b is 5 over 13, with 0 being less than b, which is less than pi over 2. So this part is in the first quadrant. And so my cosine A here, my A is in the third quadrant and my B is in the first quadrant. So first I have to look at this information, right, and kind of draw out the triangles that I've been dealing with. Since cosine of A is -4/5 and A is in my third quadrant, which we found out, so I can just kind of draw my triangle, right, as shown here in this figure. And since I have the hypotenuse and I have the adjacent side, I can just use the Pythagorean theorem to find the other side. So now I know that sine of A is this -3/5. Okay, so now I have to find the cosine of B. So again, I saw that this was in the first quadrant, so I can draw my little triangle again and find the missing side. So I know now that cosine of B is 12 over 13. So now I have the information that I need to use my difference formula to find the cosine of A minus B. So now I just use my difference formula and I plug in the things that I know that I found from drawing out my triangles, and then I can just simplify and evaluate. So the value of cosine of A minus B is a -63 over 65. Okay, so when we're dealing with stuff like this and you're only given one piece of that information, you can always use your triangles and your trig functions to help you find the other piece of information that you need. So now we're going to be simplifying the expression cosine of x plus pi. Okay, so I see here that I'm dealing with the sum formula and I'm dealing with cosine. So here is my sum formula for cosine. So now I can evaluate the things that I know, right? Because I know the cosine of pi and I know the sine of pi, so I can plug those in and then just simplify from there, and I'm left with negative cosine of x. So really we always want to just kind of first write out our sum or difference formula with all of the pieces and then evaluate it based on our unit circle. So now here are some for you to try. Definitely see how you're feeling with using the unit circle on these. So now I'm going to solve sine of x plus pi over 3 plus the sine of x minus pi over 3 equals 1. So now I'm solving some of these trig identities, but I'm also told I'm going to be looking from 0 to 2 pi, so only one revolution around my unit circle. So the first thing I want to do is write the equation out. So then I see that I have the sum formula for sine and the difference formula for sine. So I go ahead and write those formulas out and use them. So I've got sine of x cosine of pi over 3 plus cosine x sine of pi over 3 plus sine x cosine pi over 3 minus cosine x sine pi over 3. So these are just the sum and difference formulas for sine. So now I can evaluate and simplify the things that I know. So I know that the cosine of pi over 3 was 1/2, and I can just evaluate the pieces on my unit circle. So now then I simplify further. Well, I see I have square root of 3 over 2 cosine x minus square root of 3 over 2 cosine x, so that goes away. And 1/2 sine plus 1/2 sine gives me sine of x equals 1. So now I want to look back at my unit circle and see anywhere that sine of x equals 1 is going to be my actual solution. So looking back at the unit circle, and I know that sine is my y value, anywhere on this unit circle where my y value is 1 is going to be my solution. And here it's at pi over 2. So my solution is x equals pi over 2. So now we're going to be rewriting some of these real-world situations. So the index of refraction of a transparent material is the ratio of the speed of light in a vacuum to the speed of light in the material. So it tells me kind of the difference there. So a triangular prism like the one shown can be used to measure the index of refraction using this formula. Okay, so for alpha equals 60 degrees, show that the formula can be written as n equals square root of 3 over 2 plus 1/2 cotangent theta over 2. So now I'm told I have to start here and eventually end up over here. So I want to write my formula out, right? Except I know that alpha is going to be 60 because I was told that information, so I can plug that in. So I've got alpha divided by 2, which gives me 30. So now I see in the numerator I'm going to be using the sum formula for sine. So I write out the pieces that I have. I just leave the denominator alone for now. Then I can evaluate using my unit circle again, and then I can write them as separate fractions. So all I do is I take this first part over sine of theta over 2 plus the whole second part over sine of theta over 2. So write them as separate fractions because it can simplify a lot nicer that way. So then I see in my first fraction, right, my sine of theta over 2 cancels with my sine of theta over 2 because that equals 1. So I'm left with square root of 3 over 2. And over here I know I've got this 1/2. Well, I also know that cosine divided by sine gives me cotangent, so I can simplify and write that out as well. So now I've taken the information that I was given and used different formulas and different identities to help me get where I needed to go. So now here's another one that I want you to think about and try. When we're solving, don't forget we want to simplify as much as we can first, and then use that information and our unit circle to find us the actual solutions. So let's look back at our learning targets. So first we used the sum and difference formulas to evaluate and simplify trig expressions. Then we used the sum and difference formulas to solve some trig equations, and then we rewrote some real-life formulas using these different formulas. So now that we've worked on these learning targets and you have the formulas written down, go ahead and work on your homework for 9.8.